Imagine a world where cloud technologies not only propel us into the future with their limitless capabilities, but they do so in a way that's both cost effective and sustainable. With economic pressure increasing across the world, many organizations are leaning on their FinOps teams to prioritize cloud optimization. The 2024 State of FinOps report shows that this year, a top priority for organizations of all sizes is actually reducing waste and unused resources. So, this means that efficiency is high on the list of priorities right now. I'm Nataliya. I'm the Cloud Optimization Success Solution Architect at AWS. And
Hello, I'm Francesc. I'm a Principal Technical Account Manager in the Energy vertical.
in this session, we will guide you through the journey of making your AWS workloads more efficient. If you ever watched Dr. Werner Vogel's keynotes, you'd notice that he always talks about simple concepts in a thought provoking way. And at the latest reInvent, he introduced us to the frugal architect who knows how to design cost aware, sustainable, and modern applications. Being the frugal architect means that without compromising performance and availability, you should build AWS workloads where cost and sustainability are your non functional requirements. So, in this session, we will explore how to approach it. And by the end of it, you will have a list of practical tips and techniques that you can start implementing right now to make your systems more efficient. Now, creating technology solutions is a lot like constructing a physical building. If the foundation is not solid, it may cause structural problems that undermine the integrity and function of the whole building, which is why we have the AWS well-architected framework. It helps you build secure, resilient, and high-performing workloads on AWS. And when you incorporate the pillars of the framework into the design phase of your applications, it will help you produce stable and efficient systems, and therefore allowing you to focus on other functional requirements. So cost optimization and sustainability are two of the pillars of the well-architected framework. So let's see what are they all about. Um, Before diving deep into the session, we need to start from the basics and from the definitions. So cost optimization is the ability to run systems to deliver business value at the lowest price point. And sustainability is about improving efficiency of your workloads by maximizing utilization and minimizing waste. And that's why we talk about both of them in one session. Efficiency is a common theme between them. Minimizing waste and maximizing utilization of your AWS resources while paying only for what you need is our ultimate goal. Um, Moreover, cost can also be used as a proxy metric for measuring sustainability outcomes. So now, Francesc, please tell us more what else we will cover in this session.
Right. During this session, we decided to adopt this framework so you walk out of this session with quick wins or long-term success techniques that they have something in common. They are either in this first quadrant here of quick wins or long-term successes. So they all provide higher gains and measurable gains. Here to the right, we have some examples of the techniques that we will be discussing today. And as I mentioned, we will be kind of putting them into the correct quadrants so you walk out from this session with actionable and high gain and measurable techniques. So we'll start building this sustainable high performing architecture, and there are two main kind of characteristics. One, as Nataliya was mentioning before, we need to be resource efficient, so we need to make sure that we use what we need when we need it and at the right price point. And also the impact awareness, right? So we need tools to actually measure what we are realizing, what are the kind of optimizations that we are realizing. We will be using the framework that Amazon provides, the AWS well-architected framework, using the cost optimization and sustainability pillars. And as examples of tools that we will be kind of introducing today, we'll kind of introduce Trusted Advisor, Compute Optimizer, and also Nataliya will be diving a little bit deeper in cost and usage dashboards. And for optimizing storage, we will be also diving deeper into Amazon S3 storage lens.
All right. So now that we've covered the foundations, let's start optimizing. So Francesca and I have been helping customers optimize their AWS usage for many years now. Um, so we will walk you through this scenario. Now, let's imagine that we work with a company called Unicorn Rentals. They have just expanded into a new region and launched their application there. This is customers' current architecture, which you will notice it can definitely be improved, and we will be helping them optimize their workload throughout this session. It's a standard retail application that allows customers to rent unicorns, and it contains all the elements of a traditional three-tier architecture: presentation, application, and data layers. The application is running on EC2 instances spread across multiple availability zones. Amazon Aurora is used for a database, S3 and EBS for storage, and all of this is wrapped with the foundational networking infrastructure. So for example, that you'll notice that there is a NAT gateway that allows the instances to connect to any external APIs if required. So we want to recommend actionable steps to this customer to help them become more optimized. Now, there's a lot of moving elements here, right? And sometimes us customers ask us, well, where should we start? So let's see, Francesc, tell us what you would recommend to the customer. Where should they start? What should they start focusing on?
All right. Yeah, according to the 2024 State of the FinOps report, compute is still the only spending areas where the vast majority of customers have already optimization, and that's an obvious place to start, right? Normally, compute is a big part of the bill, and also a big place to optimize your sustainability, also characteristics, right, of your workload. So the goals that we typically get from customers to track efficiency outcomes are compute cost per transaction. So how much do you spend per vCPU, for example, when you are performing a business transaction like a reservation, like a sale, and then also the energy per core or per vCPU per transaction, right? So how much energy you consume by realizing this business transaction. So it's important always to relate the business transaction with the cost or the energy. So we have a realistic business metric to optimize. So as you can see in the 4 bullet points here, one of the first areas to start is by choosing the right resources for the job. Right? For that, in Amazon, we have burstable instances, which will allow you to use the CPU power that you need. And if your workload requires more, the CPU can burst over the baseline, and also attribute-based auto-scaling groups where you can specify the type of EC2 instances that you want for the job. Also, to continuously maximize the utilization, you can leverage auto-scaling groups so your workload can scale up in or out depending on the demand. Also the scheduler, so you make sure that you use your compute power when it's needed. So if there are off-peak hours, weekends where your business doesn't require that compute, you can basically stop it. And also Compute Optimizer, which is a free tool that Amazon provides and that allows you to detect when you have over provisioned resources and recommends the right resource to utilize instead. Another area that can also improve the optimization goals is the modernization. So making sure you use the right instance types and always choose the ones with best energy cost efficiency. We will be talking more about that with Graviton 3 processors in Amazon. And also, of course, design efficient architectures. So if you have a workload that can be moved to serverless containers, which are architectures that use the compute power whenever it's needed and at the right size and at the right moment, the architecture will also by itself provide these optimization goals. We will now introduce a little bit more detail on how to use the resource scheduling and auto scaling. So typically, there are environments in your workloads that do not require to be 24/7. Dev and test is a good example. And here we can see that you can achieve approximately 75% optimization, right? Just by scheduling your test and dev environments. So in this particular example, the let's say previous state running 24/7 at Event test environment, we were having a cost of $8,760, and by applying a simple scheduling on business hours and weekends, we brought it down to 75%, so approximately 2,000 euros. What tools can we use to achieve that? Well, EC2, ECS autoscaling, already built-in services in Amazon, application autoscaling also. But the instant scheduler solution, it's a free tool that Amazon provides that you can leverage by tagging your EC2 instances or RDS instances and creating your own schedule that suits your business needs. So in the next slide, we will dive deeper into the type of processors, and we will introduce Graviton. So Graviton is based on ARM. ARM typically architectures use less energy, and in the case of the Graviton 3 Amazon processors, we can see 20% less cost than comparable instances. Also, not only price, but also better price performance, so up to 40% ratio comparable to other equivalent instances. And from a sustainability point of view, also 60% less energy usage, right? So that's across all the dimensions that we were trying to optimize today. Graviton 3 provides very, very significant advantages. When you see, okay, how do I start? So typical workloads that target an optimization by leveraging Graviton 3. Those could be workloads already supporting the ARM64 architecture. So you will have to choose an AMI that supports ARM64, and typical kind of easy starting points for you if you have already services in Amazon are RDS, Lambda, EKS, Fargate, EMR that are managed services, and the transition to Graviton is done from the Amazon side. So you just need to instruct the managed service to use a Graviton instance, and we will take care of the rest. We'll move more into details of databases. So again, databases are based on compute also. So it's very important when you are optimizing your database for cost and especially for cost to choose the right database engine for the job, right? Making sure you are leveraging the right licensing model and the right kind of database type that you want to use. Also, some database engines, especially all the open source, support Graviton. So those are very good kind of candidates to apply the pattern that I was mentioning before. So you could stop the instance and change the instance type to a Graviton one if you are using an open source like Postgre or MariaDB. The right sizing and scheduling, again, it works also for RDS. So you can leverage the instance scheduler, tag your RDS instances, and if you have dev environments or business environments that are not active in certain periods like weekends, very easily can be stopped during those periods, therefore saving cost and also saving energy. So becoming your metric, your DB cost per transaction, or DB storage per user becoming a lot more efficient since you are not consuming energy or cost during those periods. On the storage part, you can also make sure that the storage auto scales so you don't over provision storage. So it is provisioned automatically when the database needs it. So you can enable easily the auto scaling feature on storage. And as a architectural improvement, also you can, in some engines like Aurora, you can move to serverless. So allowing the cluster, the Aurora cluster, to move to a serverless architecture and deploy an autoscale depending on the workload needs. As a tool that you could leverage, Trusted Advisor provides you statistics and on the idle RDSs, so it's easy for you to identify RDS instances that are not used. So you can double check those ones and make sure there are idle periods that perhaps you can apply a scheduling, and also RDS recommendations inside the RDS system, right? And typical kind of metrics that customers tend to track are the database cost per transaction and also the database storage per user. So those are clear kind of proxy metrics that you could use to verify that your optimization goals are progressing. Yeah, as we kind of introduced in the first slides, this kind of framework or quadrants, those are the techniques that we've spoken so far. They all, as promised, map in the kind of right quadrants, either low risk, easy, quick ones, or slightly more complex, but all of them having the potential of high gains and also having an attached metric that you can measure once you implement them. So we will be diving now deeper into other areas than compute. So the next one, by again, experience with our customers is storage. And EBS volumes are one of the most prevalent types of storage in our customer base. So here the optimization goal is, again, maximize utilization, making sure you don't have over-provisioned or idle EBS volumes, and also eliminate waste, right? So uh, snapshots, for example, come to mind. So making sure you have a right snapshot policy and don't have snapshots idle for many times and just not being deleted. Techniques that you could leverage for EBS volume is modernization. So by just using the latest generation of GP3 storage, you can realize already up to 20% savings without any other change, and the change is totally transparent. You can basically leverage right away 20% savings on the storage, and more importantly, you will be decoupling storage from IOPS and throughput. So you, from GP2, IOPS and throughputs are defined based on the storage size, and in GP3 those are independent parameters that you could tune. So you are not over provision IOPS and you are not over provisioning throughput. Therefore, provisioning just the resources that you need for that EBS volume, and again, improving your efficiency altogether in that EBS volume.
So
Minimize
for the
waste.
volumes, I
Mhm.
have often customers who are asking me, do they need to stop their instances? Do they need to have like any sort of downtime? Because
Mhm.
this is a valid concern from a lot of customers who to whom we talk about the modernization
Mhm.
and change into a different, let's say, volume types. What would
Mhm.
you suggest? Do they have to experience any downtime with this kind of modernization technique?
Yeah, absolutely. That's a very valid concern, and the fact is that you can trigger this transition from GP2 to GP3 without stopping the EC2 instance, right? So it could be done transparently in the background. There's no impact, so the customer doesn't need to schedule a specific kind of maintenance window. You can even snapshot your workload during the conversion, right? So it's a fully transparent uh, process to move from GP2 to GP3. So really very low kind of impact from the maintenance point of view. Highly
Great.
recommended. For minimizing waste, again, we have tools to detect idle volumes. Trusted Advisor, for example, provide you a list of idle EBS volumes. And also you can leverage AWS Management Console and CLI to list volumes that are not attached to any instance. Basically, those volumes unattached, they can be lingering in your accounts for a very long time, and just tagging them, eliminating them if they are not required in your environment are a very good way, again, to improve your overall efficiency and reduce your storage cost. And of course, maximize utilization. Following with the efficiency theme, we want to make sure that your IOPS and your throughput match exactly what your EC2 and RDS instance require. So you don't have an over-provisioned storage that provides you 10 times more IOPS or throughput that your EC2 instance is even capable to achieve, or the other way around, that you are having a bottleneck in your storage and your EC2 instance will have potential issues with performance if the storage cannot keep up. So having the possibility to define IOPS and throughput independently will allow you to match the EC2 storage bandwidth with your storage bandwidth and making sure you are fully efficient there. All right, so we move on now from EBS volumes to snapshots. That's another kind of area where many customers have a lot of optimization kind of options. So following with the goal of eliminating waste, I think one of the first kind of conversations we have with customers here is to define an RPO, a recovery point objective. So when you have a snapshot, you want to understand what's the how much time back can I go to recover my information, and that will dictate how many copies and for how long do I keep them, right? Once you have this RPO, how you have this period of time where you can recover your snapshots, then you can leverage a tool, for example, Amazon Data Lifecycle Manager, that will handle your snapshots and delete the ones that are outside of that period. So you don't keep accumulating snapshots that are not useful for your business requirements. So one other way is to tag also snapshots that are not compliant with this policy. So once you define the data lifecycle manager policy, the policy will tag the snapshots, and all the snapshots that are not tagged by the data lifecycle manager, you can easily detect with a script or with the AWS console and just delete them because they are not compliant with your policies. And then you start having a fully enforced snapshot policy that matches your business requirements. In this case, in this example, for example, you see highlighted that the snapshots have a maximum age of 7 days, right? So after 7 days, the snapshot will be deleted. So we can go as back far as 7 days.
So if I had a customer who wanted, for example, to create several different schedules or different policies for different environments, like let's say they have different requirements for production and for dev or test, you mentioned
Mhm.
something about tagging. So would it be possible?
Yes, I mean, Amazon Data Lifecycle Manager supports tagging. So you can have schedule, for example, for your dev snapshots and based on a specific tag, and then you can define another schedule for your production snapshots that perhaps would require a longer kind of RPO or being even replicated to another region. So totally possible to leverage tags there and having multiple schedules.
Yeah, that's great.
All right, so now we move on into another type of storage with is S3, very common also with our customers and also with a lot of potential for both cost and also sustainability optimization due to the scale of the storage capabilities of S3. Here again, the goal is to reduce this impact and cost of the storage, and typical kind of metrics that customers use is the gigabytes per transaction per user. And on the case of S3, because it's a highly available um, and replicated storage, it's a scaling factor defined by the storage class. Bear in mind that S3 standard is replicated to a minimum of 3 availability zones. So for every gigabyte that you have in one S3 bucket, this is replicated 3 times, right? So whatever optimization technique that you use will have at least a scaling factor of 3 if you use S3 standard, or depending on the storage class, you can have this kind of multiplying factor on your optimization techniques. One of the common places where customers can start here is use simple compression, right? So either gzip or Parquet formats before you upload your data to S3 could reduce dramatically the size of the files or the objects, and making the gains or the gigabyte per transaction or per user much more efficient. And not only that, for example, leveraging Parquet, you could reduce up to 10 times the size of a file, but also increase or reduce up to 100 times the query time, right? So if you leverage engines like Athena that support natively Parquet, format the same query using Parquet or non-compressed formats can be 100 times more efficient. And for database queries like that depend on the query time, like in Athena, that could be a very big gain also on the querying side. Another kind of technique that you can leverage is to choose the storage class. In the case of S3, we do have intelligent tiering. Intelligent tiering will take care of analyzing your objects on S3 and identifying objects that are becoming colder. So by colder, I mean that they are not being accessed for more than 30 days. How do we understand that? So intelligent tiering has a monitoring algorithm, and whatever object is not accessed for more than 30 days is transitioned to the intelligent tiering class.
Uh, So you're recommending that we use intelligent tiering on cold buckets, right, or cold objects.
Mhm.
But as a customer, how do I know which buckets are cold? How do I know that my buckets are like good candidates for intelligent tiering?
Yeah, I mean, there are, again, tools that you could leverage for that. For intelligent tiering, it's I think it's interesting to highlight that for the infrequent access tier of intelligent tiering, you can save up to 50% of the cost. And if you also enable the archive, it can save also to 82% of your cost, right? So the potential benefits are really huge. And to qualify, as you were mentioning, if your bucket is a good candidate to enable intelligent tiering, there are two parameters that are key here, right? So the average object size. So you want to move to intelligent tiering objects that are bigger than 128K in size. And for that, S3 storage lens offers a free kind of dashboard that you can leverage for that. So you can select from there the bucket that you are interested in, and it will tell you the average object size. So you can immediately see whether the average object size is bigger than 128K and if that is a good candidate. And to be able to understand also how much of your data is cold in that bucket, you could leverage S3 Analytics. Right? S3 Analytics and Insights, it's a paying service, but it's $0.1 per million objects per month. So you can enable it for 3-4 days, and you can get kind of graph like we have here in the slide, where you see the gravity of your data. So here on the x-axis, we can see the days that have passed since the data was last accessed. So, and we can see this vertical line that are 30 days, right? So anything over that 30 days are good candidates for intelligent tiering transitioning to infrequent access. So in this particular example, we can see that the data is older, more than hundreds of days, right, have been without being accessed. So making it really, really a good candidate and what we call a cold bucket. So a good candidate for enabling intelligent tiering and get this 50% on infrequent access benefits and also up to 82% in archive.
And, I guess let's finally get to the networking bit as well. So if you remember in our original diagram on the top of this slide, that's the original one, this setup is generally not ideal. And let's say if in our application, the resources within the VPC, like the EC2 instances, they have to communicate with S3 bucket in the same region, it's best if the traffic between them is not leaving the AWS network and doesn't have to jump through too many hoops. And on this example, on the top diagram, if the traffic travels from EC2 instances to S3 bucket, even though they are in the same region, same AWS region, It leaves the network through a NAT gateway and then comes back into the AWS region to reach the S3. So to simplify this, you could use gateway endpoint for S3. So in this same scenario at the bottom diagram, not only this follows like the sustainability best practices, but it also saves cost. And the data won't have to leave the network and will stay local within the region. So with this setup, on the top, you would have to pay for data transfer charges for traffic leaving your VPC, but on the bottom diagram, this traffic will be free. So the idea here from both cost and sustainability perspective is that we don't want to transmit the data unnecessarily. We want to keep local data local. In terms of the metrics or measuring, let's say, the result of some of these optimization techniques that you would implement, the goal is to reduce and simplify, and you could use things like megabytes per transaction or packets per transaction to track it potentially over time. Now, just to be clear that this is, of course, just one example and one scenario where we talk about specifically having resources inside the VPC in the region where they have to communicate with for example, Amazon S3 bucket. The whole part regarding the NAT gateway here is, there might be reasons or use cases where you need NAT gateway for a different purpose. But the idea is that, as I said, since we don't want to transmit the data necessarily and keep the local data local, whenever your resources inside VPC need to talk to S3, and similar applies, for example, to DynamoDB tables. We recommend using the VPC gateway endpoint so that those resources could talk to each other within the region without having to travel through the network, let's say, too much.
One
um,
one question, Natalia. I mean,
mhm.
do these PPC gateway endpoints for S3 work with the S3 bucket in another region?
So not exactly. You can't really have a VPC gateway endpoint to connect to the bucket in a different region. In that case, from data transfer perspective, you would still see the usage and the charges on your bill reflected as like inter-region AWS data transfer charges. So the traffic will still have to travel between two AWS regions, right? However, we actually see this as a quite common mistake. A lot of customers forget about it. They might have their resources in one region, and they might, it could be, for example, one of the European regions like EU West 1, but they might just accidentally create the S3 bucket in US East 1 or totally different region without realizing it. And then at some point they see that, oh, for some reason they have this large data transfer charges in between two different AWS regions. So the good recommendation is actually to make sure that, yeah, you keep your data local whenever possible or whenever the use case allows it. And yeah, I hope that answers the question.
Mm-hmm.
Um, Now, so we've covered different optimization techniques across multiple services. We talked about compute, storage, databases, and networking part a little bit. So let me tell you a bit more about some tools that can help you throughout the optimization journey here. If you don't know where to start, check out the Compute Optimizer. It helps to avoid over-provisioning and under-provisioning of your resources. So it's also about both cost and performance. You can start by using it either from the management payer account in organization to see the consolidated view of the recommendations across different accounts, or you can use it from individual member accounts in organization. Let's say if you are in the application team and you have one account that you're looking after, you could use Compute Optimizer to look just at your resources within your account as well. So this effectively encourages engineers to be more mindful of the best practices that we recommend to follow when building on AWS. So the Compute Optimizer Smart Engine collects utilization metrics data from resources and also resource metadata from the service information, and it evaluates your workload characteristics and analyzes potential performance risks before making any recommendations. So you can evaluate your EC2 instances, Lambda functions, ECS Fargate, tasks on whether they are over-provisioned or under-provisioned. You can check how you would benefit from upgrading to the new generation instances, or you can also see which EBS volumes could be modernized. So it has quite a lot of capabilities that provide you a lot of recommendations.
Natalia, is it free? I mean, this is a question that we get from many customers, right?
Yes, the Compute Optimizer is a free tool, and at last reInvent, we actually announced quite a lot of changes and improvements to the service. So, like for example, now you can also filter some of the recommendations based on tags. So, let's say if you're anxious to apply any of these recommendations in your production environment, you can just filter for recommendations related to resources on like development or test environments. And there were some other improvements, things like lookback period. In the past, the utilization metrics from resources that you can see in Compute Optimizer were only checking the last 14 days of, well, utilization. Now it's up to 30 days. And of course, you can also enable enhanced utilization metrics for a cost, for an extra cost, but the default period can be now 30 days. So it provides much richer recommendations based on that historical metrics data now.
All right.
All right. So now also I wanted to talk about one example of the dashboard that many of you might find useful. So let's say after learning all of the techniques that we talked about today, you will go back to your teams and start implementing some of this optimization. But then let's say you'd be curious how to track the results of your optimization efforts. So one thing that I suggest checking out is the suite of cloud intelligence dashboards. And some of you might be familiar with CAD, Kudos dashboards. It's an open source framework created by a technical community of AWS employees, which provides customers actionable insights and optimization opportunities at scale. So especially if you wanted to look at it from the organizational perspective across all of your accounts, this is a great resource. So this dashboards can be deployed by any customer using CloudFormation template or a command line tool in their environment. The tool is utilizing, so these dashboards are utilizing your cost and usage reports data and also Amazon QuickSight to visualize the results. One of the examples I wanted to mention here is the sustainability proxy dashboard. So if you remember at the beginning of the presentation, I was saying that cost can be used as a proxy for sustainability. And this dashboard is a good example how you could track these results of your optimization efforts. This is not the tool that will track the actual carbon footprint, but this dashboard is utilizing trends across specific cost and usage dimensions as a proxy metric to continuously tracking the impact of your optimization. So let's take a closer look. Currently, when deploying this dashboard, you'll see several tabs. First one will show the distribution of your cost across all AWS regions as seen on the map. And then the other three will provide highlights of the cost and usage trends for compute, storage, and networking across the usage types that can be optimized and that could have impact on both cost and sustainability goals for you. Um, for example, the compute tab, it will offer to track things like vCPU hours per compute type, like for example, your usage of EC2 versus Lambda versus ECS or EKS. You could track the vCPU hours per instance family. Like for example, you could compare older versus newer generation instance families that are used across accounts in your organization. And I'd like to zoom in on one particular visual, the EC2 vCPU hours by processors architecture. So for example, Francesc was mentioning before about the benefits of Graviton and how it impacts both cost, performance, and sustainability. So this dashboard can effectively show you over time how well you are potentially adapting Graviton across your accounts in organization. The next step is on storage, and it also provides information about cost and usage across services like EBS and S3. In case with S3, you can see the usage of different storage tiers. And for example, Francesc was talking about intelligent tiering before. You could have a goal to identify the buckets where intelligent tiering would be beneficial and then track that transition over time. And in case with EBS, you can see the breakdown of usage by different volume types. And a good idea would be to track migration from GP2 to GP3 volumes, again, across multiple accounts in your organization over time. Um, now, also the networking and the data transfer tab, which is my favorite, provides you additional information how you can be more efficient with the traffic patterns based on the trends from your cost and usage data. The goal here is to minimize waste and optimize usage. So these two specific visuals are linked together. So on the left-hand side, you can see breakdown of types of data transfer charges per account. And if you click on one of the accounts, you will then see the trend over time of the traffic patterns for that account. So you can identify if maybe there were unusual spikes or maybe unexpected periods of high load. Um, yeah, if you're curious to learn more about these dashboards, we will have a QR code on one of the last slides here. And then you can check the interactive demo in your browser. And you can also check out the setup guide if you wanted to install this dashboard on your account.
One question
Yeah.
I often have is, can this be used in a multi-account environment? So can this dashboard aggregate several payer accounts into a single dashboard?
Yeah, so generally, like for customers who might have multiple payer accounts with a lot of accounts under those, the dashboard can be set up, let's say, on one of those payer accounts. The way how it would work, you would have to like feed the data from like your cost and usage report into one of that kind of central account, where then from that one central account you could create that dashboard and you would
Mhm.
have the breakdown of these charges and usage across all of the payer accounts that you have. So that is also possible.
All
Yeah.
right.
Now we're getting close to the end of the session. Remember this original picture of the not so optimized workload? Well, hopefully, after following our recommendations, the Unicorn Rentals company implemented some best practices. So let's summarize what we've done. First, data transfer. We talked about how the traffic can be going through sort of different hoops and through different maybe availability zones. So from kind of cost and sustainability perspective, we mentioned that it would be a good idea to keep that the local data local, and don't transfer the data unnecessarily. In our case, we mentioned that in case the resources within the VPC need to talk to the S3 bucket in the same region, it's a good idea to use the VPC gateway endpoint. Then another thing is on the data subnet. So Francesc was talking about optimizing databases. A good idea here would be to, for example, switch to Graviton instances. The transition to Graviton for all the managed services that we have in AWS is quite straightforward. So yeah, that's that's what we decided to do here. Another thing is, in the original diagram, we didn't have it, the autoscaling. Autoscaling is a great resource that can help with elasticity, so that, we would only need to process the amount of traffic that we need, within those instances across different availability zones. So we decided to add some autoscaling here. And well, we also decided to move to containers because again, for this particular application, we figured that it will be much more efficient use of the compute resources. And we'll be able to utilize it much better than just simply running on EC2 instances. But now, this is all great, but is this the end? Is this like we're ultimately optimized now, or not, Francesc?
I think during the presentation, what we tried to highlight continuously is this efficiency, right? So maximize efficiency, and that kind of translates into this virtual or virtuous circle here, right? So that you should always take cost optimization and sustainability not just a reactive exercise. So when you have a high bill, try to correct it, but just put the architecture, put the proactive measure so the cost is a requirement already in your architectures. Also on the sustainability part, making sure that you are continuously looking for this efficiency, not just reacting to some idle resources or some kind of waste. So move from the reactive part to the proactive, making sure sustainability and cost are part of your non-functional requirements, and making sure that you are always kind of testing, discovering, and validating with the tools that we've talked about the impact of your initiatives. And here we can have all the techniques that we've talked today mapped into the framework. And we tried our best to be, again, on the right part, making sure that all the techniques that we provided you offer high potential gains, measurable gains. Some of them are easier, quick, low risk to try. Again, the elasticity, scheduling, an example, right sizing. You can always right size and move back to the previous instance type if it doesn't work. Move to Graviton again, try it out, make sure it fits your workload, and if it doesn't work, move back. And also a little bit more complex, like change the architecture model to serverless or event driven, which would require a little bit more study, but nevertheless have also a very high potential and lots of gains in both sustainability and cost.
Yeah, so that's great. And as we mentioned many times throughout the session, it's all about efficiency, right? So to sum it up, now we can put it into perspective. Generally, we can tell that migrating into AWS can provide you an immediate value and simplification for the total cost of ownership. Um, um, with generally our pay-as-you-go billing model. However, as you go over time, you can start optimizing and applying different techniques. Like, for example, with more flexibility, you can focus on right sizing and modernization. With the latest generation hardware, so you can use the resources that you need. You can improve elasticity and the ability to auto scale. You can also auto scale computer databases or storage depending on the demand and how it will provide further value. You would no longer need to estimate how much storage you really need, since you can effectively use as much storage as needed, and especially when it comes to S3, right? The variety of different storage solutions on AWS allow you to classify and position your data in the right storage type, class, and also lifecycle policies. And at this point, it's important to evaluate other areas where you can minimize waste and also maximize utilization to return more business value per dollar spent and align your business KPIs with the metrics to make the data-driven decisions. And with more control over cost and metrics, over time, you can make your workloads more cloud native, improving efficiency while maximizing performance. Like, for example, going serverless wherever it fits. And as a result, your workloads become more optimized to get the most value from AWS. And the whole purpose of it is to make this, continuous and to achieve the highest business value from each dollar that you spend on AWS and improve the economic case through optimization overall. So that's all we have for this session. Thanks everyone for watching, for listening. There are additional resources available if you follow this QR code. For example, this whole session originally was a workshop. We built it as a workshop. So if you're interested to learn more and read about all of these different techniques and maybe try it out as a lab in your environment, you can check that out. And there are some other resources, like, for example, the link to the Cloud Intelligence dashboards, where you can check out, let's say, the demo of the sustainability proxy dashboard that I had screenshots before, that I was talking about before. And of course, additional learning resources that you can share with your teams. So again, thanks everyone. And now you can go out and start optimizing.
Thank you.